Topic is what happens to an acid or base in a water solution. For example, you take hydrochloric acid. Take hydrochloric acid, dissolve it in water. What happens? You are getting hydronium ions H3O plus Cl minus ions. So hydrochloric acid, when dissolved in water, you are getting hydronium ions plus chloride ions. Why is water very important here? Because the separation of hydronium ions or the separation of H plus ions from HCl takes place only in presence of water. That is very important here. I can show you this equation in two steps. First, you dissolve, HCl dissolves in water to give H plus Cl minus. H plus ions alone cannot exist. They combine with water molecule. Or oxygen has a lone pair of electrons. They donate this lone pair of electrons to H plus. Why? Because what is H plus? H plus is nothing but hydrogen atomic number is 1. Hydrogen atomic number is 1. It has 1 electron, 1 proton. H plus means 1 electron is removed. Then how H plus exists with proton? So it is not possible. For this purpose, the lone pair of electrons on oxygen atom is donated to H plus. So therefore, it is written as H3O plus Cl minus. This is generally what happens when a hydrochloric acid is dissolved in water. Why is water necessary here? The separation of hydronium ions or H plus ions, you can also write H plus, but accurate H3O plus is very correct. The separation of H plus ions or hydronium ions H3O plus does not occur in absence of water. So what happens to an acid or base in a water solution? Acids, when dissolved in water, give hydronium ions. They give hydronium ions. Why is water necessary here? You are getting H3O plus ions. They give hydronium ions. They give acids, when dissolved in water, give hydronium ions. Similarly, what happens to a base when dissolved in water? For example, you take sodium hydroxide, dissolve it in water. You are getting Na plus OH minus ions, hydroxide ions. Similarly, dissolve magnesium hydroxide dissolved in water, you are getting Mg2 plus 2OH minus. Similarly, potassium hydroxide you dissolve in water, you are getting K plus OH minus ions. OH minus ions when dissolved in water. Here, bases which are soluble in water, they are called alkalis. Here you can see all these are bases. They are soluble in water. That's why they are called what? Alkalis. But all alkalis are not bases. All alkalis are not bases. What is an alkali? An alkali is a base that dissolves in water. An alkali is a base that dissolves in water. Or bases which are soluble in water, they are called alkalis. They are called alkalis. Very important here. You see, all these are bases. Why? Because they give OH minus ions. They are dissolving in water. But all bases, they are not soluble in water. They are not soluble in water. Soluble bases are called alkalis. Soluble bases are called alkalis. So, you know, from this discussion, you know, they give acids, give hydronium ions. Acids give hydronium ions. Bases give OH minus ions. Only when, what is very necessary here? Only when dissolved in water. Water is very necessary here. Water is very necessary. Water is very necessary. They generate or they give hydronium ions or hydroxide ions only when dissolved in water. Why is water very necessary? To separate H plus ions from HCl. To separate OH minus ions from NaOH. Water is very necessary. So what happens to an acid or a base in water solution? Acids give hydronium ions, bases give hydroxide ions. So I am representing an acid HX like this. HX plus, HX is nothing but any acid. You can HCl, HNO3 or something. I am representing base MOH like this. M can be NaOH, M is Na, M can be CaOH taken twice, anything. In general, a base representation, MOH. I am general representation of an acid. HX, a base, it is a base. General representation of a base, general representation of an acid. We can represent we can write HCl and NaOH also, but as per our textbook we will go. Acid which is represented as HX, MOH which is a base and represented as MOH. To give what? Acid and base react to give what? To give salt plus water. This MX is salt. MX is salt plus H2O. H2O. This is what you get. This is what you get. Okay? And you know, here, how you are getting this water? How you are getting this water? Again, it is an important one here. You are getting salt. You are getting salt. You are getting water. How you got water here? Because acids when dissolved in water give rise to H plus ions. Bases when dissolved in water give rise to OH minus ions. Aqueous, they both combine to give what? To give water. To give water. Okay? This is what we discussed up to now. What happens to an acid or a base in water solution? All acids give H plus ions. All bases give OH minus ions. And generally I represented acid as HX, base as MOH. They react with each other to give salt MX, M of base, X of acid, to give salt plus water. And you know acids, how you got water here? They give, acids give rise to H plus ions, bases give rise to OH minus. H plus OH minus. What you get? H plus 1, OH minus 1. What you get? H 1, 2, H2O you get. Now, if I ask anybody how to prepare a dilute acid, how to prepare a dilute acid, from an concentrated acid. From an concentrated acid. How to prepare a dilute acid? I have to dilute an acid in our lab. There are concentrated acids in our lab. Suppose I am asking you to prepare a dilute acid. How to carry out this procedure, or how a student what care or what precautions should a student bear in his mind before converting a concentrated acid to dilute acid. For example, one of our student, let it be some Varshit, I am saying Varshit, I am asking you to prepare a dilute sulfuric acid from concentrated sulfuric acid. I am asking you to prepare dilute sulfuric acid from concentrated sulfuric acid. What you have to do? First take beaker. First take beaker. It is filled with water. 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 First take acid. You take acid separately. Fill a beaker with water. Now you add acid to water. Add acid to water. Add acid to water. You add acid to water with constant stirring. You have to use a glass rod and stir the water when you are adding acid, or else the heat may be concentrated at one place and it may result in explosion. It may result in explosion, because the adding of acid to water is an exothermic reaction. Is an exothermic reaction. Is an exothermic reaction. Are you understanding here? I am asking one of you to prepare dilute sulfuric acid from concentrated sulfuric acid. Take acid separately. Take a beaker filled with water. Now you add acid to the water in the beaker with constant stirring with a glass rod. Why we have to stir it with glass rod? If we are adding acid, this adding acid to water is an exothermic reaction. The heat may be concentrated at one place and it may result in explosion. So when you are stirring it with glass rod, that heat is spread to the surroundings. That heat is spread to the surroundings. Never add, you should not add, you should bear in your mind that you should not add, never add water to acid. Never add water to acid. You should never add water to acid. It is very important. Add acid to water but not water to acid, because it is a highly exothermic reaction. It is a highly exothermic reaction. It may result in explosion. That's why never add water to acid. Similarly, the base also. Similarly, base when dissolved in water. Take sodium hydroxide, dissolve it in water. It is a powerful base. Dissolve it in water. You are getting what? Na plus OH minus ions. OH minus ions.